Namaskar. In this video, we will introduce periodic classification of elements and discuss about Dobereiner's classification. There are 118 elements known at the present, and it is very difficult to study the properties of all these elements separately. So, all the elements have been divided into few groups in such a way that elements in a same group have similar properties. In this way, the study of large number of elements is reduced to study of few groups of elements. This is the reason for the periodic classification of elements. We will now describe the various attempts which have been made to classify the elements from time to time. And finally, we will discuss the modern classification of elements. Let us start with the Dobereiner's trade. So, let's start with who was Dobereiner's trade. In earlier attempts, the elements were classified on the basis of their properties. All the elements having similar properties were put in one group called a family. In the year 1829, a German chemist, Dobereiner, observed that a certain element had similar properties and that he could put them together in a group of 3 elements each. These groups of 3 elements were called trades. All the 3 elements of the particular trade have similar chemical properties. In fact, Dobereiner was the first scientist to show the relationship between the properties of elements and their atomic masses. According to Dobereiner's law of trades, he said, when elements are arranged in an order of increasing atomic masses, groups of 3 elements known as trades having similar chemical properties are obtained. The atomic mass of the middle element of the trade being equal to the arithmetic mean of the atomic masses of the 2 elements. This point will become clearer from the following examples. First is the alkali metal group. The element lithium, sodium and potassium have similar chemical properties and form a trade. For example, all these elements are metals. All of them react with water to form alkalis and hydrogen gases. All of them have a valency of 1. They are monovalent. So, due to their similar chemical property, the element lithium, sodium, potassium were put in one group called alkali metal group or alkali metal family and form a Dobereiner's trade. From this table, it is clear that lithium is the first element of this trade. Sodium is the middle element, where potassium is the third element of the trade. Now, atomic mass of lithium is 7 and atomic mass of potassium is 39. So, arithmetic mean of atomic masses equals to 7 plus 39 divided by 2 of lithium and potassium equals to 23. And actual atomic mass of sodium is 23. From the calculations, we find that arithmetic mean of atomic masses of lithium and potassium is 23, which is equal to the actual atomic mass of the middle element of the trade, sodium. Thus, the atomic mass of the middle element, sodium, of this trade is equal to the arithmetic mean of atomic masses of the first element and the third element, lithium and potassium of the trade. Please note that lithium, sodium and potassium are called alkali metal because they form alkalis, caustic solution on reaction with water. Second is the alkali earth metal group. Second is the alkaline earth metal group. The elements calcium, strontium and barium have similar chemical properties and form a trade. For example, all these elements are metals. The oxides of all of them are alkaline in nature. All these elements have a valency of 2. They are divalent. So, due to their similar chemical properties, the elements calcium, strontium and barium were put in a one group called alkaline earth metal or alkali earth metal family and form a Dobereiner's trade. Now, if we calculate the arithmetic mean or average of atomic masses of the first and third member of this trade, calcium and barium, it will come to be 40 plus 137 divided by 2 equals to 88.5. And the actual atomic mass of the middle element of this trade, strontium, is 88 as shown in the table. Thus, the atomic mass of the middle element of this trade, strontium, is approximately equal to the arithmetic mean of the atomic mass of first and the third elements, calcium and barium. Please remember that the elements calcium, strontium and barium are called alkaline earth metal because their oxides are alkali in nature, which exist in the earth. These oxides were called alkaline earths and hence metals are alkaline earth metal. Third is the halogen groups. The elements chlorine, bromine and iodine have similar chemical properties and form a trade. For example, all these elements are non-metals. All these elements react with water to form acids. All these elements have valency of 1. They are monovalent. So, due to their similar chemical properties, the elements chlorine, bromine, iodine were put in one group called halogen group or halogen family and form a Dobereiner's trade. Now, if we calculate the arithmetic mean of atomic masses of the first and third member of their trades, chlorine and iodine, it will come to be 35.5 plus 127 divided by 2 equals to 81.2. And the actual atomic mass of the middle element of this trade, bromine, is 81 as shown in the table. Thus, the atomic masses of the middle element of this trade, bromine, is approximately equal to the arithmetic mean of this atomic mass of the first and the third element of this trade, chlorine and iodine. Please note that the element chlorine, bromine and iodine are known as halogens because they react with metal to form salts. The limitation of Dobereiner's classification was that it failed to arrange all the then known elements in the form of trades of the elements having similar chemical properties. Dobereiner could identify only 3 trades from the element known at that time. Hence, his classification of element was not much successful. In the next video, we will discuss about Newland's law of octave. Namaskar.